Welcome back, class. Today we're still on the topic of probability, but we're expressing probability in terms of Venn diagrams. You may have had these in English. They're very useful. You'll see them a lot in real life as a way of taking separate things and finding what they have in common, what they have in difference. Anyhow, here's the situation. Students that like football, basketball, volleyball, including those that don't like them. I'd like you to be aware of this number off to the side. This is part of the scheme, and it means that there are 10 students that don't like any of them. So the first question is, how many total students are we talking about? And this is a really important thing to get. Basically, you count up every number you see and add them together, and that's how you tell the total. So you're going to add, don't forget the 10 and 12 and 3 and 6 and 9, 11 and 4 and 15. And if you do that, it will add up to 70 students in all. Now, question 2, how many like both football and basketball? Well, this is that area where they overlap, right in here. You can see that there are 3 that like football and basketball, but not volleyball. But in terms of every group, if you consider just these 2 circles alone, the area of overlap is 3 plus 6. And so that would be a total of 9 students like both football and basketball. Now, number 3, how many only like volleyball? Well, that would be this group right here. They're not included in any others. This stands out alone. This is the group that only likes volleyball, so that would be 11. Now, how many like football and basketball, but not volleyball? So again, we're back to this segment right here. These like both football and basketball, but this 6 is the group that also likes volleyball, and we want to exclude that. So the number of those who like both these but not volleyball is that group of 3 right there. Now, how many like both basketball and volleyball? Well, here's your basketball circle, here's your volleyball circle. You have to kind of try to block out the football circle. And in terms of liking both basketball and volleyball, that's this little segment here. So it's 4 students plus 6 students. That would make 10. And finally, how many do not like both football and basketball? So you have to decide, okay, well first, how many do like both football and basketball? And earlier we said it's this group of 3 plus 6 or 9. So those that don't like both of them are everybody else. Again, don't forget that 10 students are off to the side, but since we already know the total, 70, we can subtract 9 from that. 6 plus 3 is 9, and 61 students do not like both of them. And that's the first of the basic Venn diagrams I'd like to show you. All right, students, here's a second situation where we've got 2 overlapping circles, a Venn diagram. And in this particular exercise, we're trying to define how many elements are part of each set. So we've got these various numbers. These are the ones that overlap. These are the ones that are separate. And so how many are in set A? In other words, you're only considering this particular circle. And so you want to use set notation, and that means we use a brace. And you just write down the numbers. We have the number 10, 9, 2, 5, and 3. And so that would be the elements of set A. Now, the elements of set B, similarly, we're only thinking in terms of this circle. And so it would be 7, 12, and then once again, these numbers that they have in common, 2, 5, and 3. Now these last two look unusual, but you're going to run into this notation quite a bit. This is the set of A in a union with B. You can remember union because it's shaped like a U. And so let me write that down, and I'd suggest you do it too. This stands for union, and it also means or. What elements are either in A or they're in B? So in fact, it's all of these. They're either in this or the other. And so we write down 10, 9, 7, 12, 2, 5, and 3. And this last one, we read it, what is the set of A with the intersection of B? Now the only way I can remember that that's intersection is that it's not the U, which I know U stands for union. So this other one has to be intersection. And it stands for the intersection, and it stands for the word and. What are the elements that are in both? And so that would be this area right here. And I'm going to write down here, and so this would be the numbers 2, 5, and 3. That's the intersection of sets A and set B. And that's it for the Venn diagrams.